This is raw material preparation. So every raw material, okay, there are wide portfolio of raw material. Every raw material needs to be prepared before molding. It's not just open the bag and put it inside the hopper and mold it. No. So what is a raw material preparation? Raw material preparation includes storing of the raw material, transportation, mixing. If there is a master batch or color or whatever you are mixing, and the fourth is drying, in which drying is, all other things are very quite logical things: storage, transportation, mixing, everybody knows. But drying is the gray area. Everybody tends to make mistakes and start blame games. Storage, just storage, I'll tell you, storage of any plastic, thermoplastic raw materials shelf life is not defined. If anybody asks, how many months this thermoplastic can be kept, I bought 100 kilo of polycarbonate, how many months it can be kept? There is no answer to that question. This is like an anda murgi story. You ask the raw material people, they'll tell no. You again ask, because shelf life is not there. If you ask a mobile phone, your car is made of plastic. No, some people run that vehicle for 20, 30 years also. Some people put do all the miss these things and improper usage and damage. It is like it's plastic only. So storage, how we should store the plastic? It should be, the storage condition should be away from heat, direct heat, light or moisture. That's all. And any dust and all. If you are keeping that in this proper condition storage, then thermoplastic can be used even after 2 years, 3 or 5 years. Its property will not change. But suppose if you are keeping the that bag of the plastic near the window wherever sunlight comes, you are telling I am kept in a proper area, but sunlight comes, nobody might have seen, and in the winter season moisture might have come, already humidity is there. Then what happens? Its property changes, it damages. So storage should be away from the heat, sunlight, direct sunlight or any temperature on moisture. That's all. And transportation the same way. And mixing, there is nothing to tell in mixing. Master batch is there, how to mix, grind is, there is nothing. It's just a logical thing. What is the proportionate? You have to use it. Fourth is drying. Drying we will be covering in detail. Very, very important subject. This is an apparatus used for pre-drying plastic. This is done as pre-dryer. Every plastic and every metal absorbs certain amount moisture from the atmosphere. Paper absorbs some moisture, cloth absorbs moisture, wood absorbs moisture, get fungus. Similar way, plastic also. It's not plastic never absorbs moisture. It absorbs, but very little, up to its saturation limit. There is a saturation limit. There is a limit. No, there are There are, you see, kids diapers, urine absorbing diapers. When we keep it, it absorbs lot of urine. Kid use, no, and that is a polymer. That is a super absorbent polymer. Cotton absorbs lesser than that. Like that, our plastic also up to a certain limit, that is known as a saturation limit. Polycarbonate absorbed to 0.5%. Noryl, the least, Devendraji, whatever Devendraji is using, absorb the least, and it absorbs 0.1%. That is why it is used for those solar application. I used to get, whenever I was in Sabi, I used to get more complaint from Mumbai area. Moisture, your part is having silver mark. Why? Because Mumbai, the place is already humid. So plastic easily absorbs. But Bangalore, we never get that problem. Silver mark. Because Bangalore humidity is very, very lesser. So wherever humidity is there, more silver mark problem come. Because plastic, these granules absorb the moisture from the atmosphere up to a certain saturation limit. So you can see, this is the plastic molecules, all these red things. So this is H2O is water. It connects, it comes and joins with that molecules of the plastic. This is known as saturation. So whenever we heat that, these water particles evaporates and go away, then material will be intact. We are not heating that, preheating that, this moisture mixed material which having moisture goes into the machine, it heats up, and that moisture becomes steam. and mix with the part and becomes a silver mark. That is how silver marks comes in the part. So this is a pre-drying. So every material, polycarbonate is dry to 100 to 120 degree. Every polymer has its own temperature. So why I have to give 100 degree? Instead of 100 degree, I'll heat for 10 hours, 60 degree. No. For that molecular to push out the water from that, it requires that temperature. It is not that it keeps on heating for 24 hours. No. So what is the temperature? Polycarbonate 100 degree. As the our polymers goes from engineering and specialty, the heating temperature also will increase, and it should be in a particular time. It is not like I can heat it for a long time. What happens when we are overheating? There is a chance for overheating. I am now I am taking a trial. I put the metal inside the okay, and heated it. 4 hours heated, a mold damage. I removed that metal. Again tomorrow I am putting. Again I am again mold some machine some problem. I removed that metal again. This is not a cumulative drying time. This material again and again heated. So the raw material is not just raw material. Inside there are a lot of additives. One is the flow agent is there. One is the mold release additive is there. Mold, inside the mold, the molten metal goes and sticks. Should be removed, So there is a release agent is there. Then there is an agent for metal is going to burn. It should stop the burning. Fire retardant additives there. Multiple additives there inside the raw material. If you are overheating that, some are volatile. It escapes. Overheating, everything will escapes. So I had an experience when I was Schneider. The part, whenever we take a trial, initially everything was smooth. Polycarbonate 10% glass fill, fire retardant grade, and everything was smooth, no issue at all. And after second half evening, all the parts, very good mold. Parts started sticking the mold, and ejector mark will come on the part, ejector. So we were checking cooling lines, MTC, everything was proper. There is no change at all. Then finally, we were narrowed down everything, understood the heat, the pre-dryer capacity, small part, and capacity was quite high. It was heating since that material require a cumulative drying time of 6 hours. This was getting heated 22 hours like that. So it was keeping on getting overheating, and the mold release additive inside that was getting volatile and evaporated. You will get a same part, but it started sticking to the mold, and ejector started piercing. So this is a result of overheating. So we should heat optimally in a time. So our some of the material is having cumulative. Polycarbonate can be heated 20-25 hours cumulatively, no problem. But like Ultim or like Peak and all, if you heat for more time, you'll get problem. Your part will not come out of the mold itself. It will stay in the mold. Sometimes part will injection pressure, huge injection pressure, you will again inject. Instead of some pressure, you have to give more pressure. So all these problems comes. So overheating also should be prevented. And third is a wet material. Okay, I told material will absorb the water up to a saturation limit. Okay, polycarbonate absorb up to 0.5%. Nylon absorb more, like 1%, 2% nylon absorbs. That's why nylon we tell it as a hygroscopic material. It absorbs more water. Some of the nylon switches not push button, and all, some people get fungus in that. In the winter season, they used to, we don't know why it is fungus coming. So they put anti-fungus inside that, anti-fungus master batches. Because nylon, it absorbs whole water, and water, it's fungus will happen. More water, fungus will happen. They don't know why fungus is happening. They tell your material is a problem. Problem is rainy season, it is absorbing more water. And moreover, they molded part, to prevent warpage, they are putting it in the water. Whenever part comes, they put in the water. So again, more water. So that was an issue. So we should be able to correlate those things. And third thing is wet material. Wet material means direct rain, or somebody, by mistake, some water has fallen over that. It is not a wet material. Whatever drying you do, you cannot remove that material water from by pre-drying. So if wet has happened, If from the supplier, you tell them and directly give back to them. From your side, again it start to go for recompounding and repalletizing, because it water completely goes into the pores of the granules. It has to be dry, kept inside and dried, and but most probably once it is wet, very difficult to again take back to the other normal condition, especially for hygroscopic material like nylon, PBT and all. Once wet, better to throw away that material. Or if you have a non-critical part, backside part and all, then this material will not give any performance. Mechanical property also damage, aesthetic, not only aesthetic, mechanical property, because water goes inside the flow barrel, it heats and become a steam, it mixes with the raw material, is not just plastic, it's a steam mixed plastic, bubbles will be there. Now we'll go to drying methods. What are the drying? There are a lot of drying methods seen inside our industry. What are the methods? So first is a oven, and second is a hopper dryer. This everybody might have seen in our molding shops. Oven is just, I call it as a pizza oven. You can tell it's like a pizza. Where we'll bake the pizza, heat the pizza, make the pizza. It's similar like to that. We'll keep the raw material inside in the tray and keep it inside and keep the temperature of a 1 to 2 hours, whatever prescribed with the raw material. Raw material, people specify what temperature up to what time. In that we'll keep, and we'll remove it and put in the machine. It is away from the machine or near to the machine. It is not attached to the machine. First one. Inside that there will be a tray. In this tray, this is used for small batch of run, or not for a long run or critical thing. Small batch, this can be used, or for a normal plastic which is not so much water absorbing property, hygroscopic property. And this, whenever we are using this, we have to take care that whatever tray is there, we should not fill complete the tray. We should fill 70% or whatever. There should be a room for air to circulate. If you completely fill and just brush it off, air will not go. So to air go, we should have some gap. So 60-70% you should fill and keep it. That is all what. This is recommended only for normal plastic, which are small drum. Second is a hopper dryer, quite often seen everywhere. Hopper dryer will be attached to the machine. In this, what happens? We will be putting raw material inside the this vessel, and there will be heater. There is a heater here. You can control the temperature here, and there will be a blower here. Air blower sucks the air from outside, from the atmosphere, and heat it and send to the material from the bottom side, and the hot air will be passing through the material, and whatever moisture is there, air will take it and go outside. This is a procedure. Okay, so atmosphere air sucked, heated, and sent to the raw material, and it is thrown out. That air will take away the moisture. But in this oven type dryer, no circulation is there. Whatever whatever air that is there inside, it just heat and circulate inside. That's all. Here fan pulls air, and this is more effective, and pushes through and takes it out. So this is more effective. This is not, because whatever capacity inside, that only air is there. So it circulates inside there. This is what? This is two types, and this is the third one. This is the actual recommended from engineering plastic and hygroscopic plastic. In this, what is the difference? No, we will not suck first of all the atmospheric air, because atmospheric air will have certain amount of moisture based on the weather condition, humidity. On the winter season, higher amount of humidity, so it sucks all the humidity from outside, so it cannot properly dry the raw material. So in this case, what happens? Air will be going through a desiccant, like a silica gel. No, we used to keep in shoes and all. Whenever we buy a shoes and all, silica is the silica gel. What is the property? It absorbs whatever moisture of that only. Inside the clothes, it comes, clothes and all, it comes. So it absorbs. So similar way, this is not a desiccant bed. It has a silica type of desiccant which absorbs. It is capability of absorbing all the water. So air is passed through that desiccant. Absorbed air, moisture, without moisture, air is passed to the raw material, and it goes to the material, and whatever there in the material, it sucks. The same air comes out from the this. Again, it is passed, heated, and passed through this, and again recirculated. So what happens? There is no moisture. This is a closed system. There is no moisture in the outside of the whatever condition in our atmosphere, it's not affected. Okay, this system, because it just pass whatever air inside this unit, it absorbs, heats and send it back, absorb, heat and send it back. That's all. So this is the best type of dryer. If you have to have a better part and a very aesthetically important, no silver mark on this, this is used, but it's a little costly affair. This equipment is costly. So heated material, heated air goes inside, then it goes out, then again it, and here there are two desiccants. Okay, after certain time, one desiccant will be fully loaded with moisture, then it will not, it also will not function. It saturation might have reached. Then what happen? It steps to the next desiccant bed. That's why two has two one. How we can understand whether our material is properly dried or not? If we mold the part, keep on taking the shot, our part will be lost, our cost will be lost. So by looking at the raw material, no, we known as purging, we will push the raw material from the nozzle, just inject it, and see the purging quality. We can understand whether moisture is there or not, is correctly prepared or not. So what is the sign of a poor purging? Poor purging means there will be frothy, like bubbles, and bubbles like shape is not a smooth purging. When we take it, it will come, you can hear the voice, tip 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 tip, some voice will come. It will not be smooth flow, and if you stop the machine also, automatically material comes out. It's not a drooling, because moisture is there. Moisture will become like fumes and steam, and it pushes, it expands, so automatically material comes out from the nozzle. These are the signs of poor pre-drying or not prepared properly. And your short flow rate will change. Moisture is inside the material, so what happens? It expands. So sometime flash will come, some short will come. Your flow rate, plastic flow rate inside the cavity in the part will keep on changing, because we can control the plastic flow, but we cannot control the water, or because plastic when melted have a uniform flow, so flow rate will change. And inside the part there will be voids means bubbles. You can see bubbles in the part, and on top of the surface of the part you can see marks, like line like silver type of marks, play marks. And in the part also you can see, in the purging also you can see. And your part may be brittle also. So whenever it is not a hydrolysis, whenever water is mixed in the material, the H2O molecules will react with the plastic raw material molecules, and it change the property. It is not a hydrolysis. With that, what happens? Our part will become brittle. Sometimes it can crack also. So how a good sign is, you can see smooth toothpaste. Like when you purge it, it gives a very good smooth shape. It means our raw material is properly dried. If the dew point is lesser, means lesser humidity. In a this is a desert. First desert there is no humidity. The dew point you can see 34 Fahrenheit. In a pleasant atmosphere, it is in between, 54. Okay, in the, if you are having a molding shop in this area, you have to pre-dry at that in a better condition. But in a desert, pre-drying may not be so much relevant, because there will not be moisture inside the raw material. If you go to the third one, is like a Mumbai or Shimla, wherever so much moisture is there, more than Mumbai, some cold weather area, like a snow area, there you have to use dehumidifier only, because atmosphere already moisture, so plastic obviously will absorb moisture. So that is what the difference, place to place. So Mumbai people tell I have more problem, Bangalore less problem, because Bangalore lesser. This is a moisture analyzer. Moisture analyzer is an instrument to check, to understand whether we are doing a right, whether some people may not be able, critical part, we may not be able to, looking at the part raw material, we may not be, moisture is there or not. So this is a better, this instrument is costly. Some of the critical parts molding people keep it very critical. And how the function is, this is just comparing the weight. This part is a very digitized, precise weighing machine. We'll put a few grams of 3, 4, 5 grams of raw material in this pan, and we'll close it. So inside this apparatus, there is a xenon arc, high temperature is happening. So it heats the raw material. So due to that heat, If there is a moisture, that moisture get evaporated, and the raw material, whatever we have kept, granule weight will reduce. So there is a granule 5 gram, and there will be water content also, no, little moisture. So moisture content will add up to the weight. Okay, when we close and heat, it's a auto mode, we'll heat it. What happen? That whatever moisture evaporates, so there is a reduction in weight. So this machine compare before that process and after that heating process, everything is done automatically, and it gives what is the percentage of moisture in that material. Sometimes it shows normally any molding material for taking the molding should be 0.02 percentage. That is the best moisture level. You cannot make 0.00%. We'll understand whether this material have 1% or 0.5%, whatever we'll come to know using this moisture apparatus. That is a function of this moisture apparatus. We will be drying, but our apparatus will be damaged. Heater will not be working. People keep on drying. I done for 4 hours, 8 hours. No, my machine, my dryer is proper. But we compare in this apparatus, we'll come to know whether that heater might have damage in the hopper dryer. Then also heating will not have. We feel it is heated up. So from here, even some of the raw material comes in a wet material, you supplier might have supplied you wet by mistake. Then if you keep it inside, it will show 2%, 3%, 5% moisture. It means it is a wet material. We may not know looking at the material. Nylon sometimes so much moisture absorbed, you cannot cure it. You have to return it back. So much moisture absorption. So you can understand using this apparatus. You can show that this is what